This video will be about using JSON to create a hydropower parameter. To do this, we will be using the Eastern Nile model. It is recommended that you make a copy of this model. That way you don't alter the original. Now to make a copy, we will click the share button. We will type in your own, this is sharing it with yourself, so you'll type in your own email. And we're going to call this network. Just going to add power target. Alright, as you can see, our copy has been made. Now go into our copy. Now for this video, we will be using the Merowe Dam in Sudan. Alright, currently for this reservoir, it is being controlled by a linear storage release control node. Now we are looking to change that. Well, first we'll look at what that is. Wants to open. So as you can see, there's an allocation penalty of -3, and we can look at the release values. So a linear storage release node works that it correlates the amount of water being released to the volume of the storage. So for example, when it is completely full, it'll be releasing 300 million meters cubed per day. So we're going to go ahead and delete this node. Alright, now we are going to replace the linear storage node with a river node. And this will help us satisfy our power target release. We're then going to use the link feature and connect the reservoir to the river node, the river node to the turbine, and the river node to the link over here as an overflow. And there we go. Right, now we want to deactivate the link tool and close the build menu. We will go into our river node. So we're going to make the allocation penalty -3 like it was before. Alright. Now we want to change the max, or put our operating rules in the max flow. This will allow us to achieve the power target we are looking for. So first we will go to options. We're going to change the type to a PyWR parameter. We'll be using a PyWR hydropower parameter here. Select OK. And now you can see we have a JSON window. Alright. So in order to insert the parameter that we would like, we are going to go to a PyWR's documentation page, which has information on everything PyWR. For us, we are looking for descriptions of parameters and recorders. In this case, a parameter. We're going to go to the Python API reference. Inside the reference documentation, we can go to the parameters area and click on hydropower parameters. Then we will go to hydropower target parameter, the only hydropower parameter. Now the first thing we must do when using a parameter is specifying the type. So we will go back to our model and quotations, we'll type colon, and we will copy and paste hydropower target parameter. Comma, enter. All right, now we need to specify our target and our water elevation parameter. We are going to ignore these for now and come back to them, as they both involve parameters or based on parameters. You can specify a max flow. This would be the absolute maximum that can pass or that can be released from the reservoir. We're going to ignore that. We're also going to ignore the mid flow. We're going to ignore the mid head. We do need to specify the turbine elevation, and this needs to correlate, or not correlate, it needs to be the same specified turbine elevation as the node downstream, the turbine node downstream. So we'll put turbine elevation in quotations and specify it as 245. That is what it is downstream, or specified downstream. We also need to specify the efficiency of the turbine, and once again it needs to be the same as what the turbine is defined downstream. Oops, get the E there. So we'll copy efficiency, paste it in quotations, colon. Downstream it is 0.85. You can specify the density of water. The default is 1,000. That's fine for our purposes here. You can change that as needed. The flow unit conversion we do need to specify. We are currently in million meters cubed per day, and we are looking to get that into meters cubed per second. That number will be 11.574. And the energy unit conversion, copy, put that in quotations. The power equation outputs watts when provided with a flow of meters cubed per second, head in meters, and a density in metric units. We are looking to get it into megawatts, and therefore we will be multiplying by a millionth. Alright, let's go to the last two inputs we haven't specified, which is target and water elevation parameter. So we will copy target. We're going to put that under here. Paste inside parentheses. And now we're going to nest a new parameter inside target, which will output a target value. The first, we're going to use two parameters today. The first one we're going to use for our target parameter is going to be a simple parameter, and it's going to be the constant parameter. So we can copy constant parameter, and we will then, in quotations, write type, colon, constant parameter. This needs to be in quotations as well. And the other thing we need to specify is a value, as you can see here. For this, we'll use 850 megawatts. All right, we want to make sure that there is a comma after this input. And then we're going to go to our last input, which is in hydropower target parameter. So we need a water elevation parameter input. So we're going to copy that. We're going to paste it in quotes. And we're going to nest another parameter inside this. That parameter is going to be under interpolation parameters, and it's the interpolated volume parameter. For this parameter, there are 4 inputs: the node, volumes, values, and the interpolation. To save time, I have already written this parameter, this nested parameter. So as you can see, the type is interpolated volume parameter. The node is the Meroe reservoir. The volumes and the value data are directly copied from the volume and level data of the Meroe reservoir node. If they are not the same, the run might not work, or the power results might be incorrect. So for example, a volume of 89.6 correlates to an elevation of 256, and the interpolation is linear. So we're going to go ahead and click Save. Oh, before we click Save, it should be noted that you can use the Format button to organize your code. And we're going to click Save. So now we're going to go ahead and run the model. Click Submit. Alright, now that the run is complete, let's look at the power generation of the turbine node, and we can do that by going down to the outputs. You can see the simulated hydropower recorder value. Oh, that's the wrong one. And on the plot, you can see that it is all 850 megawatts. Now if we go to the reservoir and look at the outputs, you can see that the volume is constantly changing in the reservoir as it is trying to keep up with the power demand required. Now obviously that's a very simple power target. It's unrealistic, and power demand usually fluctuates. So I'm going to show you how to now create a changing power demand. Alright, so in order to do that, we're going to go back into the max flow of the river node, hit edit, and instead of our constant parameter for our power target, I'm going to replace it with a monthly profile, and I've already pre-written this. Now this works that each month there's a different power demand, and there should be 12 total. Format once again to make it look nice. We're going to click Save. Alright, so now we're going to run the model again with this new information. Alright, if we go to the turbine node now, go down to the outputs, simulated hydropower recorder, we can now see that the power is fluctuating as by month. Thank you for watching.